You asked me if an ordinary person, by studying hard, would get to be able to imagine these things like I imagine them. Of course, I was an ordinary person who studied hard. There's no miracle people. It just happens they got interested in this thing, and they learned all this stuff. They're just people. There's no talent, a special miracle ability to understand quantum mechanics or a miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and time, then he's become a scientist. The great difference in what goes on in the head when people think they're doing the same thing. And so it struck me, therefore, if that's already true at the most elementary level, that when we learn mathematics and the Bessel functions and the exponentials and the electric fields and all these things, that the imageries and method by which we're storing it all and the way we think about it could be really, if we could get into each other's heads, entirely different. And in fact, why somebody sometimes has a great deal of difficulty understanding a point which you see as obvious, and vice versa, it may be because it's a little hard to translate what you just said into his particular framework and so on. Now I'm talking like a psychologist, and you know I know nothing about this. Suppose that little things behaved very differently than anything that was big. Anything that you're familiar with, because you see, as the animal evolves and so on, and his brain evolves, it gets used to handling, and the brain is designed for ordinary circumstances. But if the gut particles and the deep inner workings were by some other rules and some other character, they behaved differently, they were very different than anything on a large scale, then there would be some kind of difficulty in understanding and imagining reality. And that difficulty we are in. The behavior of things on a small scale is so fantastic. It's so wonderfully different, so marvelously different than anything that behaves on a large scale. You say electrons act like waves. No, they don't exactly. They act like particles. No, they don't exactly. They act like a kind of a fog around the nucleus. No, they don't exactly. And if you would like to get a clear, sharp picture of an atom, so that you can tell exactly how it's going to behave correctly, and have a good image, in other words, a really good image of reality, I don't know how to do it. Because that image has to be mathematical. We have a mathematical expression, strange as mathematics, I don't understand how it is, but we can write mathematical expressions and calculate what the thing is going to do without actually being able to picture it. It would be something like a computer that you put certain numbers in and you have the formula for at what time the car will arrive at different destinations, and the thing does the arithmetic to figure out what time the car arrives at the different destinations, but cannot picture the car. It's just doing the arithmetic. So we know how to do the arithmetic, but we cannot picture the car. No, it's not 100%, because for certain approximate situations, a certain kind of approximate picture works, that is simply a fog around the nucleus that when you squeeze it, it repels you, is very good for understanding the stiffness of material. That it's a wave which does this and that is very good for some other phenomenon. All right? So when you're working with certain particular aspects of the behavior of atoms, for instance, when I was talking about temperature and so forth, that they're just little balls is good enough, and it gives a very nice picture of temperature.
Hello guys. Hi. Sorry, my laptop had a problem with the last minute, so I couldn't make it on time. I was like 2 minutes late, I guess. So, am I audible? கேக்குதா நான் பேசுறது?
Yes.
Okay, great. Super. So, as we move, I want you guys to simply be interactive as possible. And quickly we are jumping into today's topic. But before that, I want to know who's here. So just type your name and the thing that you do currently. Like if you are somebody who is in school, put your name, which grade you are studying. If you are from a college, put your name and what degree you study, like that. Okay, let's do it. Let's do it quickly. Uh, Keithna, can you unpin me? Don't pin anything. Okay, Lakshya from 8th grade, Sanjita from 7th grade. Great. Nice. There's so many school graders, I guess. Okay, okay. Others, I'm just waiting. Oh, now I get to see people. Thank you, Hari Krishnan. And people, if you can, please open up your cameras. That will be great. Sai from grade 6, Nelson from BEC final year, super. Hari Krishnan from physics. Wonderful, wonderful. Thank you. Thank you so much. Thank you, Lakshya, for opening your camera. Oh, my camera is off. Oh my God. I didn't see that. Okay. Okay, great. Wonderful. Wonderful to see people. Okay. So you guys are here for what? What is that one thing that you want to learn today? What is that one thing that you are expecting from this webinar today? Just one simple thing. You can just be like, I just want to be happy. I mean, if you're somebody who really cares about learning things, then it might be a happy thing for you. But at least let's see if somebody is like that. But what is that one thing that you're looking for today? That's the question. Is it Suma? I just came, or what's that one thing? Just want to know more about know more things. Okay, great, great. People, it'd be nice if you can open your cameras, uh, because nobody's gonna say anything. If you, it would be nice, no, to see your faces and talk. Please, what is that one thing that you're expecting today? Yeah, black holes. I mean, black holes on itself, by itself, it's like very fantastic thing, and it requires a ton of different session. I mean, we'll also see that black hole today, but yeah, what is that other things that you want to learn, or what is that something that you're looking for? எதுக்கு வந்தோம்னே தெரியாமலாம் வந்தீங்க? What is this, guys? Oh my God. People இருக்கீங்களா இல்ல is it just சும்மா bots? By any chance does Google Meet allow bots to come in, and then what is this concept? Okay, to know something about black holes. Okay, okay. Great. Quickly நீங்க டக்குன்னு சொன்னீங்கன்னா டக்கு நானும் முடிச்சுட்டு போயிடுவேன். Okay, I'm just waiting for you guys. Please type down something. Thank you, Jay, for opening your cameras. Okay, then I'm assuming that you're not ready or interested to. Thank you, Ashmi, for opening camera. Or interested to say why you are here. Anyway, but I am here to share you some very interesting things today. Uh, that's, I mean, the idea of this coming into my head was something interesting. Okay, so I started presenting. I'll just stop presenting. I'll just tell you why I sort of uh, decided to do this. Because I recently got a gift from one of my friends. That's this. Okay. You know what this is?
Bubble gun.
Oh yeah, it's a bubble gun. Okay. So I recently got this from a friend, and I thought, okay, this is very interesting, and I thought I didn't even test this. Immediate thought of mine was, okay, we are doing a webinar on from black holes to, I mean, sorry, from bubbles to black holes, because there is like so many connections that I could see. So I really want to take you through this understanding, and then see if I can share the beautiful thing that I have in my head to you. Okay. Shall we move? Yes. Give me a thumbs up in the chat. Or
Yes.
in the chat section. Super. Okay, thank you. You can also open your. Wonderful. So let's proceed. There is something common that you get to see for a black hole and a bubble. What is that in the first place? By the way, don't expect me to just give you a lecture. I really want to interact and then I expect answers from you as well. Doesn't matter if it is right, wrong. And is there somebody யாருக்கா தமிழ் தெரியாது இங்கிலீஷ் தெரியாதுன்னு யாராவது இருக்கீங்க? No, right? Both everyone understands these two language because அதுதான் எனக்கு தெரியும். So I can only talk in that. Sphere, vacuum. Is it vacuum? Are you sure? Okay, keep this question in your mind. Bubble உள்ள vacuum இருக்குமா? அதான் என்னோட question இப்போ. So if someone knows the answer or someone wants to argue, you can. If you want to do now, you can do now. Or else, as we move, I'll reveal that particular thing. So someone who's that GVR VVP. So he says that vacuum is something common. Okay, the question was, what is the relation that you think is between a soap bubble and a black hole? Hari says it's pure. I mean, it's just that at this point of time. But as we complete this entire webinar, you get to see there's like slightly more to it also. Okay, shall we move? Yeah. So okay. So again, yeah, it's not only with the black hole. Okay, it's with anything and everything you see, or at least most of the things. Okay, this is like a beautiful thing that I learned about this nature. Okay, which again we have done a webinar before on this particular topic, which I try to sort of cover a little also. Like moving on, so this gets to have, you get to see this everywhere, starting from like the cosmic scale to something even smaller. Can you name something that is spherical in a smaller scale? The cosmic scale na டக்குனு நமக்கு ஞாபகம் வந்துரும். Your stars, your planets and stuff, most of them are in the sphere shapeல இருப்பாங்க. Probably somebody who's here who knows better might say planet on the sphere shape இல்லையே அப்படின்னு. I have an answer for that as well, so just don't be agitated at this point. Let's move. What is that small scale ல ரெகுலரா பாக்குற விஷயத்துல sphere எங்க பாப்பீங்க? Sphere. Subatomic particles. Okay, subatomic particles spherical இருக்குமா? Okay. Normal, the balls that you find around. Okay. Anything else? Like common materials, 11. Okay, orange இருக்குதா 11 on. Okay, even smaller. Let's go little less in the scale. So that's the topic. Eh? Where that's it. Come on. Globe. What globe? something smaller. Goalie. Okay, nice. What is that? Jay, கொஞ்சம் கிட்ட காட்டுறீங்களா? Explain what is it?
That's a lamp.
Oh, lamp. Okay. It has that this thing inside. Okay. Nice. Okay, let's just let's see. I don't know. I missed the slide. There are most of your fruits and even some cells are spherical in shape. Where else do you find? I mean, இப்போ நம்ம objecta materialistica சொன்னோம் இல்லையா? Again, this is also materialistic, but nature has this beautiful way of doing things. So இந்த மாதிரி repeated spheres ஒரு இடத்துல இருக்கும். எந்த இடம்? Repeated spheres. I know at this point I'm confusing. There is a place where there are like repeated spheres, and you would have. I mean, like a sphere is சொன்னதால you would have, your mind won't think that place, but it's repeated spheres. It's a home. It's a home for something. It's just repeated sphere. It's a home. It belongs. I mean, the home is a home of an insect. Like somebody said, honeybee. How many of them think honeybees that comb structure is the this thing, or is that hexagon? How many of them think that it's hexagon? Answer is, or perhaps இது வரைக்கும், okay? Who thought it was hexagon? Most of us. Actually, it is not hexagon. It is actually sphere. I mean, the circle, okay, in the two dimensions. So what happens is that they're like bunch of circles together. Those walls, they would stick, and then they become straight. Okay, there's a nice way you could test this for yourself. Take some soap. Probably I'll just quickly do it. What you can do is that take some soap, add some sugar. In this case, I have added some glycerin to it. You can also add glycerin if you have. So, and then take some straw. கையை வந்து நல்லா வெட் பண்ணி தண்ணியில விட்டுட்டு you blow ஒரு a bubble and then do this. இப்படி பண்ணி பாருங்க. You get to see that the interface between you and your இது இருக்கு இல்லையா, இது வந்து ஸ்ட்ரைட்டா இருக்கும். And also this curve, அது spherical இருக்காது. It'll just turn into a straight thing. So what I'm trying to tell you is that when things merge, what happens is that it becomes straight. And that is why இப்போ ஒரு ஸ்பியரை சுத்தி இங்கோர் ஸ்பியர் அப்படி சுத்தி எல்லா இடத்துலயும் இருக்கு அப்படின்னா what happens is that they combine together, those walls combine together, and then they form that hexagon shape. And that is what you get to see in a honeycomb. And please keep this idea in your head. It is not the honeybee that does this thing. It's the nature itself doing that thing. We'll also sort of uncover those things as well moving forward. Okay? Are you with me still? I mean, so far, are you with me? Yeah. Is there any confusion? Is there anything that that's bothering? I'm assuming that it's no. Okay. Good. Shall we move? Yeah. So now for today's webinar, the mystery that we are trying to uncover is why it is here. Why not some other shape? Okay. The real question is why it is here and why not some other shape? Why not a cube or a cylinder or a pyramid or some diamond or anything like that, right? So why is it so? On the question simple answer பண்ணனும் அப்படின்னா, let's just quickly do a math calculation. Okay, ரொம்ப simple calculation. Don't அப்படியே mathனா அப்படியே no வைஷ்ணவியோட பேஸ் அப்படியே இந்த பக்கம் போகுது. Don't worry, it's not, we are not going to do anything more than a simple math that we have probably done. I'll just, yeah, this is math. Okay, please take your notebook or your mobile phone as anything like that. So இப்போ நான் இங்க கொடுத்துருக்கேன். இப்போ இங்க A வந்து 1 கொடுத்துருக்கேன், இந்த பக்கம் R வந்துட்டு 0.62 அப்படி கொடுத்துருக்கேன். அதுக்கு ரீசன் என்னன்னா, என்னோட வால்யூமை நான் வந்து ஃபிக்ஸ் பண்ணி வச்சிருக்கேன் இப்போதைக்கு. ஓகே, இப்போ நீங்க இந்த நம்பர் கிளிக் பண்ணீங்க அப்படின்னா ரெண்டுத்தோட வால்யூமும் 1ன்னு வரும். ஓகே, ரெண்டுத்தோட வால்யூமும் 1ன்னு வரும். ஸோ அதனாலதான் இந்த நம்பர். ஸோ டோன்ட் திங்க் டூ மச் ஏன் இந்த நம்பர் வந்துச்சுன்னா, ஜஸ்ட் ரிவர்ஸ் கால்குலேட்டட் அண்ட் தென் காட் திஸ் நம்பர். ஃபார் நவ் ஜஸ்ட் ஃபாலோ த இன்ஸ்ட்ரக்ஷன்ஸ் அண்ட் தென் let's just blindly go and see where we sort of end up. Okay, so இந்த வால்யூம் ஃபார்முலால v equal to a cube இருக்குல்ல, அதுல 1 போட்டீங்கன்னா என்ன வரும்? வால்யூம் 1 தான். அப்படியே இங்க ஸ்பியர் இருக்கு, ஸ்பியர்ல 4/3 pi r cube இருக்கு. சோ அங்க அந்த r கியூபுக்கு பதிலா 0.6203 approximately. So you just put two numbers, or if you're using calculator, put all the numbers, and then as a port just give me the answer for that particular thing. I'll also parallelly calculate.
Point 99999, nearly 1.
Okay, எல்லாருக்கும் அதே ஆன்சர் வந்துச்சா? Yes, no, yes. Please give me a thumbs up if you got the answer. Super. So approximately 1. So அந்த நம்பருக்காக தான். Okay, so this is not the matter because I have already said that it is going to be 1. Now let's go down and then calculate the surface area. That is what we are most interested in. Okay, so let's just quickly do the surface area. If you got the answer, put it in the chat, no? இப்படி மொட்டையா 4.83 போட்டா எதுக்கு 4.83 எதுக்கு 4 பாயிண்ட் ஐ மீன் வாட் எவர் தட் அது போடணும்ல. கியூப்கா ஸ்பியர்கா? கியூப். Okay, okay. For cube it's 6, and for sphere is this. And please always learn to um okay, good, fine. Okay, keep that numbers in your head, and then let's go back to see that golden rule. Okay, so basically what the entire idea is that nature doesn't care how beautifully this is being constructed, and that is why I really said that honeycomb it's not the honeybee that is building that hexagon structure or anything. It's the nature that itself it is sort of building. Honeycomb or structure பார்க்க ரொம்ப அழகா இருக்கும். ஓகே, இஃப் யூ ஹவ் நோட்டிஸ், அழகா எல்லாத்தோட அந்த லைன்ஸும் அப்படியே ஒரே ஒரே இதா இருக்கும், ஒரே லைன்ல அப்படியே இருக்கும். That looks nice, but it is not that nature is caring about the beauty, but nature is caring something more than that. And that thing is this golden rule, which is always you move towards the direction of the lowest energy possible. Okay, whichever that takes the lowest amount of energy, lowest amount of time, lowest amount of force, lowest amount of anything for that fact, just go that lowest amount of material. So why nature chooses this hexagon pattern or perhaps that a round pattern and then later turning that into an hexagon is that is the lowest pattern with which, sorry, so that is the lowest material. இப்போ பி வேக்ஸ் பி வந்து அந்த இது கட்டணும்னா இட் நீட்ஸ் சம் வேக்ஸ், நோ. லோவஸ்ட் மெட்டீரியல் எந்த ஷேப்ல இருக்கும் அப்படின்னா இந்த sphere shape, which is later turned into a hexagon. Okay, so it takes the lowest amount of material to build that structure, and that is why your honeycomb is in that structure. So you go anywhere, you take anything, nature always wants to go and then seek the lowest thing possible. Okay, this is what in classical mechanics or in statistical mechanics you call it the least action principle. Okay, one of the most fundamental and beautiful physics that you would ever sort of hear. Okay, and it is the same reason why your light bends inside the water. It's the same reason why most of the things that you see in the universe is the way it is. Got it? I'm not going deep into the least action principle as such, but if somebody is interested, probably after the end we can see if someone is there to talk about that. Let's quickly move on. So with that being said, I would sort of go, I mean, இப்போ இங்க நம்ம இப்போ ஏன் இது மத்த ஷேப்ல இல்ல அப்படின்னா the cost of the surface area. Okay, இப்போ it can be anything. Okay, இப்போ நான் வந்து honeycomb, honeybee அந்த வயசுல பேசும்போது how much amount of wax it is going to take me அப்படிங்கிறது தான் என்னோட மேஜர் திங்கா இருந்துச்சு. So இப்போ let's just imagine that there are two types of bees. Okay, ஒரு bee is building its அதோட home in a in a cube pattern. Okay, cube அதோட home கட்டுது. இன்னொன்னு யூஸ்வல் ஸ்பெரிக்கல் ஷேப்ல கட்டுது, அப்படி வச்சுப்போம். ஓகே, சோ இப்போ அதுக்கு தான் நம்ம கால்குலேட் பண்ணோம். ஓகே, இங்க டன் இப்போ நம்ம அதுக்கு தான் கால்குலேட் பண்ணோம் அப்படின்னு நினைச்சுக்கோங்க. ஓகே, யூ கால்குலேட்டட் அகைன். நான் ஏன் வந்து வால்யூம் வந்து யூனிட்டா எடுத்துக்கிட்டேன் அப்படின்னா, ஸோ தட் இஸ் ஃபார் ஆர் கம்பேரிசன். வால்யூம் யூனிட்டா எடுத்துக்கு வால்யூம் யூனிட்னா வால்யூம் ஈக்குவல் டு 1 அப்படின்னு எடுத்துக்கு ரீசன் என்னன்னா, தட்ஸ் பிகாஸ் amount of stuff that I can fill in is same now. Okay, புரியுதா? Doesn't matter if it's a cube, doesn't matter if it's a sphere, the amount of matter that you can stuff in, be it honey, let's just take honey. So நான் வந்து இந்த கியூப்குள்ள ஒன் வால்யூம் உள்ள ஒரு கியூபா இருந்துச்சுன்னா, யூனிட் வால்யூம் உள்ள ஒரு கியூபா இருந்துச்சுன்னா, let's say அதுல 10 grams of honey, சும்மா சொல்றேன், 10 grams of honey போட முடியும் அப்படின்னா, ஸோ இப்போ 0.6203 அப்படிங்கிற ரேடியஸ்ல ஒரு ஸ்பியர் இருக்குன்னா அந்த ஸ்பியருக்குள்ளேயே என்னால 10 grams of honey தான் போட முடியும். Got it? Then that is the reason why I kept the V equal to 1. Now you get to compare the A, okay, which is the surface area. What does it take to build that surface area? Surface is the outside, okay, outer thing that we are gonna do. So நீங்களே அப்படியே சொல்லுங்க which has the least amount, which has the highest amount. நீங்க கால்குலேட் பண்ணதுல இருந்து சொல்லுங்க.
Sphere has the least amount.
Okay, so to hold 10 grams of honey, இந்த மாதிரி ஒரு ஸ்பியர் பில்ட் பண்ணாதான் கம்மியான வேக்ஸ்ல you can build the 10 gram vessel. இதுவே ஒரு கியூப் பில்ட் பண்றீங்க அப்படின்னா உங்களுக்கு எக்ஸ்ட்ரா எவ்வளவு வரும்? ஒரு 1 பாயிண்ட் சம்திங் வருமா? I just calculated also. So here it is. Okay, it's approximately 4.84. அங்க வந்து 6. Okay, you have the difference la, and the difference தான் the cost difference, meaning the wax difference. Okay, to hold the same volume, to hold the same amount, ஒரு கியூப்ல உங்களுக்கு 6 யூனிட்ஸ் தேவைப்படுது, ஒரு ஸ்பியர்ல உங்களுக்கு வெறும் 4.8 யூனிட்ஸ் தான் தேவைப்படுது. You get to see the difference. Yeah, so that is why this surface, that is why the sphere shape is like more valuable for the the nature. It's like 20% difference. If you go and calculate, it's 20% difference. So 20% energy saved, 20% material saved, 20% time saved, right? So that is the trade-off why everything and anything is sphere. But it cannot just be that, correct? இப்போ நம்ம மேத் போட்டு இவ்வளவு கால்குலேஷன் பண்றோம், நேச்சர் அந்த மாதிரி உட்காந்து கால்குலேஷன் பண்ணி does the nature does this? No. So your immediate question to me should be, Gokul, how nature knows this? Gokul, how nature knows this? Like we are doing the calculation right now, and we get to see that there's a difference. And obviously, if you are building a home, assuming that there is no restriction, if நமக்கு ஒரு வீடு கட்டுறோம் அப்படின்னா ஒரு ஸ்பியர் ஷேப்ல கட்டினா நமக்கு கம்மியாகும் அப்படின்னா I would obviously go do that sphere shape. ஒரு ட்ரையாங்கிளோ ரெக்டாங்கிளோ whatever ஷேப்ல கட்டணும்னா நான் அதை பண்றேன், because I know the calculation, I get to see that math. But what is that one thing which is dictating the nature to do this? Hari, I'm not expecting answers from you right now. I want others to answer. I think you understood my question. Who is dictating nature to do this? யார் நேச்சர் கிட்ட போய் சொல்றா, nature that cube has 6 and the sphere has 4.8 and nature கிட்ட யார் சொல்றா? So least action is not going and telling. It's just a principle. It's just like our understanding of what the universe is. Least action principle explanation இருக்கு. Okay, how it follows the least action அப்படின்னு. But now my ரொம்ப சிம்பிள் தான். நீங்க ரொம்ப அப்படியே அவுட் ஆஃப் த பாக்ஸ்ல யோசிக்கணும், ஏதோ கேட்கறான் அப்படிலாம் நினைக்காதீங்க. ரொம்ப சிம்பிளான திங். ஜஸ்ட் you guys know the answer. Come on. தப்பா இருந்தா பரவாயில்ல. Who is going to ask? Science. Vaishnavi. Okay, what part of science is dictating that particularly? You're very close then. No. See, I see, you have to understand the thing. Like எல்லாமே ஸ்பியரா இருக்குல்ல. What is creating that sphere is what I'm asking. I'm not like why nature prefers it. Optimization, correct. எல்லாமே correct. Whatever you saying are right. எல்லாம். But the question is, what is dictating that particular thing to do so? Atoms. We are not yet touched the atoms. I mean, next அதுதான் அங்கதான் போறோம். But we have not yet touched the atoms. Molecules, no. Atmosphere, close. Gravity for the next session, yes. Gravity is for the next session, but for now, let's only talk in terms of bubbles, soap bubble. For the soap bubble, what is dictating the soap bubble to be spherical? Planets, droplets, stars, எல்லாமே are a very good example of what a sphere in nature is. But I'm just exactly surface tension. Okay, basically the answer that I was expecting was force. Basically, simple force. because it applies everywhere. Nanasingla, Lakshya, right? Lakshya, Nanasingla force. That's okay. That's why you need to open and tell what you think. Okay, sometimes we might be right and then we think we are wrong. Okay, so the whole point is just force. Force is something that is dictating the entire universe to be in that optimal state, to be in that state where it takes less amount of time, less amount of energy, and less amount of everything. Right? Done? Got it? Purida? Done? But how? How is force dictating that? Well, it dictates via certain particular force. In this case, in our case, it's surface tension. Now, what's the surface tension? As simple as it sounds. Tell me what is surface tension. ஏன் இந்த மையான அமைதி பேசு? நீங்க மைக் ஓபன் பண்ணி பேசலாம். ஓகே, தப்பா சொன்னா பரவாயில்ல. Surface, bond of the molecules in the surface of a medium, super. There's a tendency of a liquid surface to behave like a stretched elastic sheet. Wow. That's straight from a textbook. Manapanam panningala Vaishnavi? Okay, force created by liquids. Right. I mean, by the way, I know Vaishnavi, I know Hare Krishna and all, and Vaishnavi is not at all our domain. She's studying 12th, but commerce group. But she loves to learn these things, and that's why I just said, good Vaishnavi. Okay, force created by liquids. Yeah. So it's basically some kind of attraction between the, attraction between the molecules as such. Okay, that is the force that we are more interested in. I'll quickly share. Okay, don't worry. I think you guys are not here for like deeper mathematics as such. I assume that, and then I'm just being super light at a scale. Oh my god, yeah. So the surface tension. You know what surface tension does to the soap the bubble? Surface tension தான். Surface tension அந்த சர்ஃபேஸ்ல இருக்க எல்லா மாலிகுல்ஸும் அட்ராக்ட் ஆயிருக்கும். ஏன் அட்ராக்ட் ஆயிருக்கும் அப்படின்னா கீழே வேற அட்ராக்ஷன் பண்றதுக்கு வேற எதுவும் இல்லை. ஸோ தி அட்ராக்ஷன் டபுள்ஸ் ஓவர் த சர்ஃபேஸ். இட்ஸ் குட். ஓகே, அதெல்லாம் அசியூமிங் தெரியும். யாருக்காவது சர்ஃபேஸ் டென்ஷன் பத்தி ஐடியாவே இல்லை, இட்ஸ் வெரி நியூ டேர்ம், அப்படி யாராவது இருக்கீங்களா? Should I sort of explain? Or இருக்கீங்களா இல்ல shall I move?
Continue பண்ணுங்க.
Okay, I'm assuming that everyone knows. Please, உங்களுக்கு தெரியலனா நீங்க தான் சொல்லணும். ஓகேயா? I mean, I know science, I don't know mind reading, I don't know face reading, I don't know profile reading, and also just bear with me. So this surface tension is some kind of attraction that things has on the surface, right? Now the bubble surface also has the surface tension, but you know what the surface tension does to the bubble? That is where the core of what we are about to talk today, which is the black holes and stuff like that. That is where the core idea is. When I take a question, okay, what is the surface tension doing to the bubble? If you know this, if you can think this, then the rest is just simply easy thing.
Surface tension makes the bubble float. Float.
Bubble float up. No.
Float or vibrate.
It makes it to vibrate? Okay. Where? The question is, in the surface tension, in the bubble kondu pannum. Okay. The surface tension will do something to the bubble. What does it do? It keeps the bubble in shape. Are you sure?
Yes.
How many of them think it tries to keep the bubble in the shape? Hands raise. One, two. That's all. It pulls the bubble. Okay. I get to see 3, 4. Okay, 4 hands, 5 hands. Okay. If you think in one way, this is right, but my idea is don't think in that way. Okay, if you're going to think in that way, then you lose the core idea of what the connections that these things have. It does not help the bubble to be in that shape. It technically squeezes the bubble. It tries to, I mean, see, sphere da stablest shape na solliyachu. Sphere da efficient shape na solliyachu. But the real question is, what sphere at which radius is stable? That should be our next question. Sphere at which radius is stable? Right? Is it இவ்ளோ பெரிய sphere shape stable ஆ இருக்குமா இல்ல இவ்ளோ பெரிய stable ஆ இருக்குமா இல்ல இத்துணுண்டு stable ஆ இருக்குமா? Which one is more stable?
Small.
Smaller. Yes, the smaller
No,
will be the like the more
no,
stable.
More
And
stable.
that's not, yeah.
no. Sun is
Smaller
very big.
will,
Still it is stable. Sun is very big.
bigger
Still
one
it
will
is
be stable.
stable.
Oh, sun is very big. Okay. Keep that idea in your head. We'll come back there. Okay. So technically, the smallest structure are the stablest. If you see, குட்டி பபிள் ஊதுனீங்கன்னு வச்சுக்கோங்களேன், சின்னோண்டு ஒரு பபிள் ஊதுனீங்கன்னா அதை போட்டு இப்படி நசுக்கிறதே ரொம்ப கஷ்டமா இருக்கும், உடையாது. ஓகே, குட்டி பபிள். இஃப் யூ ஹேவ் அ பிகர் பபிள், லைட்டா இப்படி டாப் பண்ணாலே உடஞ்சிரும். ஓகே, இதெல்லாம் நான் இப்ப ஏன் உங்ககிட்ட சொல்றேன் அப்படின்னா, யூ ஹேவ் டு கோ பை சம் பபிள் அண்ட் தென் டூ இட், ஆர் அட்லீஸ்ட் கெட் சம் சிக் ஷாம்பு அண்ட் தென் புட் இட் இன் அ கண்டெய்னர், ஆட் சம் சுகர், add some water, mix it, and then blow it using a straw or something. Okay, please do this. Okay, go and experience it. You get to learn so much with just the things that you have at your home. So குட்டி பபிள உடைக்கிறது கஷ்டமா இருக்கும். குட்டி பபிள் கையில இருக்குன்னா அதை பிடிச்சி உடைக்கிறது கஷ்டமா இருக்கும். ஒரு பெரிய பபிள் ஈஸியா உடைஞ்சிரும். That's because the more strongest shape is the sphere with the curvature, with the more curvature, with a more curved surface, which is the smallest one. Okay. The point is, then the entire, அப்போ எவ்வளவு பெரிய பபிளா ஊதுனா அந்த பபிள் அப்படியே சின்னதாக தானே ட்ரை பண்ணணும், ரைட்? The surface tension should pull them. எல்லா சைட்ல அந்த surface tension இழுக்குது அப்படின்னா it should just go and then implode. கரெக்டா? பட் அந்த மாதிரி நம்ம பார்க்க மாட்டோம். It will still be stable at some sort of equilibrium, and that's completely because there is no vacuum inside your bubble. If somebody said there's vacuum, no, there's no vacuum inside the bubble. Okay, it's basically there's air inside, there's air outside, right? So இப்போ ஒரு பலூன் எடுத்துக்கிட்டீங்க வச்சுக்கோங்களேன், இந்த பலூனை ஊதிட்டு கம்ப்ரஸ் பண்றீங்க அப்படின்னா அமுக்கலாம், பட் ஒரு லெவலுக்கு மேல அமுக்க முடியாது. That's because உள்ள there's something, there's some matter inside. You cannot compress a matter to like to make it like to go into a tiny drop at normal situation. Note this point, at normal situation. At normal situation, that's what I mean. Okay, so now this the surface tension is kind of compressing the air down, trying to compress the air down, but air summa irukadu, air will also push it out eliye po appdi. So these two forces sort of balance each other, and that is what dictates which shape should the bubble be the stablest, right? It can be the smallest, it can be the largest. Okay, உள்ள எவ்வளவு ஏர் இருக்கு, உள்ள கம்மியான ஏர் இருந்தா then the smallest bubble is the stablest. Done. So as the number of air inside increases, your bubble size will also increases. Done. So it balances out. Are we good with this? The heart of where we are, I mean, why we are here today. Okay, got it?
Yeah, got it.
Yes, any questions with this? Give me a thumbs up if you got it. And I just out. Okay, super. Done. Okay, perfect. So with that being said, I'm going to ask you, what if we replace the force with something else? I mean, the surface tension force with some other force. Basically, I'm pushing. Now we've understood the science of bubbles. Okay, at a scale. Okay, not the fullest, but a tiny track of the thing that we are interested today. What I'm trying to do is that now we'll apply this to a bigger stuff. Okay, to a more solid stuff. Okay, I'm replacing every single thing with an atom. Okay, somebody like was asking, ஓகே ஆட்டம்ஸா மாலிகுல்ஸா அப்படின்னு. ஸோ ஐம் ரீப்ளேசிங் த இப்போ ஆட்டம்ஸ் மாலிகுல்ஸ் தான் அப்படியே கொஞ்சம் சாலிடா போறேன். ஓகே ஐம் ஜஸ்ட் கோயிங் டு ரீப்ளேஸ் த ஃபோர்ஸ். ஓகே திஸ் இஸ் வாட் ஐ செட். ஓகே டைனியா இருக்கும்போது ஏன் வந்து ஸ்டேபிளா இருக்குன்னா அந்த ப்ரெஷர் உள்ள இருக்குல்ல. ஸோ தட் சார்ட் ஆஃப் மேட்சஸ் அவுட். ஓகே ஸோ அதனாலதான் அந்த குட்டியா இருக்கிறத வந்து அமுக்கும் போது இட் ஜஸ்ட் dramatically escapes from our stuff. Okay, from our hand. Okay. I'm just quickly being said. This applies to everything. Okay, that is what I want to tell you. This is the pattern. So now I'm swapping the certain things. Now I'm replacing certain things. Okay, இப்போ நம்ம இங்க இந்த soap bubble படிச்சத அப்படியே we are going to use it for something else, which is like a physical solid stuff, and then replace the force with gravity. Got it? So that's what we are going to do. Similar signs, and that is why I'm sort of connecting. Okay, let's start with Earth itself. Why Earth is in the shape of a sphere? Again, don't bite me saying that it's not the perfect sphere. There's a reason for that, but for now, just be with me. Why is the Earth being sphere? I want you to answer because I've already explained you every single thing. So there's no point in again explaining everything. Who wants to go? I'm happy to hear. Gravity pulls it from the center. Okay. நான் இப்போ நான் வந்து ஒரு half an hour உங்களுக்கு இவ்வளோ இதுதான் சொல்லி கொடுத்த கிராவிட்டி. நான் அப்ப வந்தோடனே நான் சொல்லியிருக்கலாம்ல சர்ஃபேஸ் டென்ஷன் புல் surface tension compresses it and the air pushes it out. அப்படி சொல்லியிருக்கலாம்ல. Can you be little more expressive when you sort of explain something? What happens? Gravity pulls, and then what happens? That's all. Gravity pulls now. Then my next question is, won't it be just like a small point? Why it is not a small point? What is happening then?
The amount of pressure inside the sphere and outside the sphere is more than equal.
Okay, so he has a point. Amount of sphere sort of balances out. Okay, what kind of pressure here sort of happens? What is that force that அங்க வந்து நம்ம ஏர் பிரஷர்னு சொன்னோம். ஏர் பிரஷரும் சர்ஃபேஸ் டென்ஷனால வர பிரஷர்னு சொன்னோம். இப்போ இங்க என்ன நடக்கும்? வாட் இஸ் தட்? ஈக்குவலன்ட் இங்க என்னன்னு கேக்குறேன். அட்மாஸ்பியரிக் பிரஷரா? Are you sure?
No, I think so.
You think so? Okay.
Sir, can you please repeat the question?
Okay, see, இப்போ நம்ம என்ன பண்றோம்னா அந்த பபிள் பார்த்தோம்ல அதே மாதிரி எர்த்துக்கு அப்ளை பண்றோம். ஓகே, பபிள அப்படியே எர்த்துக்கு அப்ளை பண்றோம். ஸோ பபிள் எப்படி சர்ஃபேஸ் டென்ஷன் இருந்துச்சு, அதுக்கப்புறம் வெளியில உள்ள ஏர் ப்ரெஷர் வந்து அதை வெளியே புஷ் பண்ணுச்சு அப்படின்னு பேசினோமோ, இங்க இது வந்து இந்த மாதிரி ஸ்பெரிக்கலா இருக்க வாட் இஸ் தட் விச் இஸ் ஹெல்பிங்? கிராவிட்டின்னு சொல்லிட்டாங்க. ஓகே, கிராவிட்டி இஸ் லைக் புல்லிங் தெம் டுவர்ட்ஸ் தி சென்டர் அப்படின்னு சொல்லிட்டாங்க. My immediate question is why it is not out of going and imploding. Done. So அப்போ ஒரு இன்டர்னல் ப்ரெஷர் இருக்கு அப்படின்னு சொல்லிட்டு விஜய் சொன்னாங்க. What is that internal pressure அப்படின்னு நான் கேட்கிறேன். Then what is that external pressure? What is that internal pressure? What is it? Pressure from the core
Center
and the
of
mantle of the earth being.
So,
Okay.
So each atoms will have a specific pressure which will separate them outside. And the pressure வந்துட்டு பாதுகாத்துக்கணும்.
அந்த pressure பாதுகாத்துட்டு இருக்கோம். Nice. That's all. That is what I'm asking. You don't have to tell me any technical terms. அப்பதான் நான் புரிஞ்சுக்கலாம். Just give me, guys. Throw your ideas. Why so silent?
Internal and external force of the Earth's surface.
Internal hard surface.
Internal and external forces of the Earth's surface.
Internal and external forces of the Earth's surface. Okay.
Beyond the gravity, இப்போ லேண்ட் கீழேயுமே சென்டர் ஆஃப் த ஆரிஜின் இருக்கு. அபோவ் த ஏருமே அட்மாஸ்பியர், ஸ்ட்ராட்டோஸ்பியர், ட்ராப்போஸ்பியர், நமக்கு வந்து நம்ம டிஃப்ரெண்ட் லெவல் ஆஃப் ப்ரெஷர்ஸ் இருக்கு. ஸோ ரெண்டு ப்ரெஷருமே வந்து போத் ஈக்குவலா ஹேண்டில் பண்றதுக்கு சென்டர் ஆஃப் த ஆரிஜின் வந்து சேம் அமௌண்ட் ஆஃப் ப்ரெஷரை ஜீரோல வச்சிருக்கு.
சூப்பர், நைஸ். See, there's no right answer, wrong answer. நீங்க சொன்ன எல்லாமே ரைட் ஆன்சர் தான். ஓகேவா? I'm just I'm just pushing you just to make sure that you come out and then you speak. Okay, shall we move? Okay, it's basically the forces balances out. Okay, as simple as it sounds, and the rest is you guys said. Uh, oh yeah. So now we'll be like talking why the Earth is not a perfect sphere. Earth வந்து ஒரு perfect sphere கிடையாது, right? How many of them know this?
Yeah, I know.
So what is the shape called?
Geoid.
Called geoid. So it's geoid in shape. So your immediate question should be sphere தான் இவ்வளவு நேரம் அப்படின்னு பேசிட்டு இருந்த நம்ம ஏன் geoid அப்படின்னு பேசிட்டு இருக்கோம்? Why ஏன் sphere வந்து ஏன் லைக் Earth ஒரு perfect sphere இருந்திருக்கலாம்ல? Why it is not?
So மூனோட இன்ஃப்ளூயன்ஸால.
மூனோட இன்ஃப்ளூயன்ஸ்னால. ஓகே. Gravity from the sun and moon. Okay.
Asteroids எல்லாம் hit பண்ணிட்டு அது அப்படி ஆயிடுச்சு.
Yeah, nice. So, I mean, since you said asteroid, then look at an asteroid. What is the shape of an asteroid? Quickly, what is the shape of an asteroid?
Rock-like shape.
Anybody? Not for Navin. I mean, not for Narmada. I'm just generally asking, what is the shape of the asteroid?
Rock-like shape.
It's irregular.
Rock-like shape. Irregular. Yeah, that's the word I want. Irregular shape. There's no shape particularly. It can be any shape. Okay. Go learn about Oumuamua comet. I am guessing I'm pronouncing it right. Oumuamua something. Okay. Go check that out. There's a very interesting thing that you can learn. Okay. So it can be in any shape. This particular Oumuamua comet will be like ஒரு மாதிரி இப்படி நீட்டமா இருக்கும். ஓகே. ஸோ இட் வில் பி irregular in shape. நான் இப்பதான் சொன்னேன் தட் ஸ்பியர் தான் ஒரு பர்ஃபெக்ட் ஷேப் அப்படின்லாம் சொல்லிட்டு. பட் ஏன் irregular ஷேப்ல இந்த மாதிரி ஆஸ்ட்ராய்ட்ஸ் இருக்குன்னா அகைன் எண்ட் ஆஃப் தி ரைட். ஸோ இஃப் இட்ஸ் லைக் வெரி ஸ்மாலர் இன் சைஸ் then the influence of gravity is very less. Okay. And the material it is made of also matters at certain level. So அதனாலதான் ஆஸ்ட்ராய்டு வந்து கொஞ்சம் டிஃப்ரெண்ட் ஷேப்ல இருக்கு. அண்ட் நீங்க பிளானட்ஸ் எல்லாம் பாத்தீங்க அப்படின்னா ரொம்ப ராக்கி பிளானட்ஸ் இல்ல ரொம்ப ரொம்ப சின்ன பிளானட்ஸ் அர்த் சைஸ் பிளானட்ஸ் எல்லாம் கொஞ்சம் இந்த மாதிரி டீஃபார்ம் ஷேப்ல தான் இருக்கும். பட் இஃப் யூ கோ டு ஸ்டார்ஸ், வாட் இஸ் த ஷேப் ஆஃப் அ ஸ்டார்?
Sphere.
யா, கண்ணு மூச்சு சொல்லலாம் ஸ்பியர். ஓகே. பிகாஸ் the gravity is enormous. That the gravity is not allowing anything to move out, basically, right? So it forms that sphere. Okay, so the bigger the mass is, that the more beautifully spherical it is. Got it? Purida? Done? So because the force then gets higher and higher. Okay, we are heading close to something more interesting. Okay, the force is getting higher. As I said, we are also heading towards something more interesting.
Bro,
So I mean,
sorry
this
to
is what I
stop
mean.
you.
Like low mass, irna konjam. Yeah.
Is it true that star is a sphere shape?
Yes.
இல்ல நான் கேள்விப்பட்டதுல just now learned. Thanks.
Oh, you just now learned அப்படிங்கிறீங்களா? Okay. ஓ, நீங்க ஸ்டார் ஷேப்ல இருக்கும் நினைச்சிட்டீங்களா?
இல்ல அது வந்து ஷேப்லெஸ்ன்ற மாதிரி பார்த்த மாதிரி ஞாபகம்.
ஷேப்லெஸ். ஓகே. நோ. See, இப்போ சன்னோட கொரோனா இருக்குல்ல,
ஆமா,
which is the things that it is ejecting, அதுக்கெல்லாம் ஷேப் இல்ல. Okay, it's like the actual surface, the thing that I'm talking about, okay, அது is spherical. Of course, அது மேல இருக்க பிளாஸ்மா, அந்த கொரோனா ejecting, அதெல்லாம் it is not bound, it is like shapeless தான். What you're thinking is right. Just the idea is like that the surface part of it is a sphere.
Okay.
Yeah. So மாஸ் அதிகமாக உங்களுக்கு அந்த ஷேப்பும் கொஞ்சம் ஆப்வியஸா ஸ்பெரிக்கலா மாறும். That so I mean, oh my god, I just revealed it. யாரா பாத்தீங்களா? அப்பா இல்ல, stupid. Okay. we are at the very edge now. We are at the very edge of touching something about black holes. So now tell me what black hole is. See, I've said you what this bubble is. I explained you the science. We have put that science into action and saw that all the astronomical sized objects also follow the same. But here the gravity and the internal pressure sort of changes. Of course, I'm going to explain what happens inside the star. But I want you to now tell me what this black hole is.
So sun after its retirement or after its death.
A nice word to use, yeah. Sun after its retirement.
Something like Dead
Nice.
Star.
Oh yeah, Death Star. Yeah. A death of a star. Yes. So what happens with that? What burns the star?
Hydrogen.
Is it really burning or what is it?
Fission.
Nuclear fission. Fusion.
யார் இப்ப கரெக்ட் ஃபிஷனா ஃபியூஷனா நீங்களே பேசி முடிவு பண்ணி வரணும்
Nuclear fusion happens in the sun.
Oh yeah. So it's basically fusion that happened. Okay. So what happens with now I want to really break a myth. Probably இதை நான் அன்னைக்கு போன வாரம் பண்ணியிருக்கணும் பட் ஜஸ்ட் நீங்க இப்ப சொல்றதுனால ஃபியூஷன் நடக்கும் உள்ள என்னென்ன ஃபியூஸ் ஆகும் what and what fuses?
Hydrogen to helium, helium to carbon, carbon to iron, iron to white dwarf, and then black hole.
Iron to white dwarf. Okay. She's telling that அது முடிஞ்ச அப்புறம் white dwarf அப்படி போகும் அப்படின்னு. That's okay. Fine. So if you noticed, அவங்க சொல்லும் போது she started from helium, hydrogen to hydrogen, becomes helium, then something else brings something, and then what was the last product?
I think last one is iron. I think.
Okay.
Carbon.
How many of them think
and
last product is iron? How many of them think last product that happens to be formed inside a sun is iron? It is true. The last product that forms inside a sun is or a star is iron. Okay, that's because of something called binding energy. That also is very similar to what we are sort of learning right now. The bubble, the surface tension, surface pressure, all of those things directly relate that with the binding energy. ஒரு பாயிண்ட்க்கு மேல பைண்டிங் எனர்ஜி அப்படியே ஸ்டீப்பா போயிடும். Okay, if you notice binding energy in your graph, by any chance if somebody is doing BSc in physics or any related field, you would probably learn about a binding energy graph with something, and you get to see it starts like this. ஒரு இடத்துல fluctuation இருக்கும், and then it goes linearly like this. Okay, and the maximum என்னவா இருக்கும் அப்படின்னா அது அயன் தான். ஓகே, அயனால ஃபியூஸ் ஆக முடியாது. ஓகே, அதுக்கு மேல ஃபியூஷன் நடக்காது, அதுக்கு மேல ஃபிஷன் நடக்கும். ஓகே, அயனுக்கு மேல இருக்க இதெல்லாம் வந்து ஃபிஷன் நடக்கும், அயனுக்கு கீழே இருக்கிறதுக்கெல்லாம் ஃபியூஷன் நடக்கும். ஃபார் whom it is new thing, இப்ப நான் சொன்ன ஒரு மேட்டர், இந்த பைண்டிங் எனர்ஜி, ஃபியூஷன் till iron only. Okay, great, perfect. Go check binding energy graph. That'll be very interesting again. Okay, moving on. So now tell me, what is keeping the star in that shape? What is determining the star's radius at a point? To put it simple, what is determining the star's radius? The balance between which two forces?
The amount of molecules inside the star.
The amount of molecule inside a star. Of course, somebody said ஒரு ரெண்டு ஆட்டம் இருக்குன்னா ஒரு பாயிண்ட்க்கு மேல அவங்களால கம்ப்ரஸ்லாம் பண்ண முடியாது. அந்த ஆட்டம் it cannot be in same place, right? So Pauli's explosion. இது what is that? Why I just forgot that name? Oh my god. I just forgot the name. Okay, வரும்போது நான் சொல்றேன். This beautiful term for it. Okay. What is the two things that balances the star's radius,
Gravity and pressure.
star's diameter. Gravity and pressure. Super. Gravity, of course, no doubt about it. What pressure?
The pressure from outside the star and inside the star.
Pressure from outside the star is the gravity, no? Like gravity is pulling inside. Like the other things like coming outside. What is the pushing outside? You have to think that
The
way.
pressure from hot gas and then fusion made inside.
Is that
Okay,
called
so,
exothermic pressure? Is that pressure called exothermic?
I don't know if it is called. You can call it an exothermic pressure, but somebody please check that and then tell me. But it's called the fusion pressure. Okay, to put it in simple words. Also called hydrostatic equilibrium. Hydrostatic energy, hydrostatic force in போட்டா உங்களுக்கு காட்ட போறது தப்பா இருக்கும். Hydrostatic equilibrium தான் would talk about the pressure that happens that matches between your fusion that is happening inside versus the gravity that is pulling things inside. Okay, so this is what determines so உள்ள எவ்வளோ fusion நடக்குது or perhaps உள்ள வந்து எவ்வளோ content இருக்கு, amount of stuff that you have inside that is undergoing fusion, that will determine the star's kind of shape. Okay, I mean shape, the radius. Then if it is like more, then the shape would be different. Okay, like a little bit bigger. Okay, ஏன்னா அந்த பாயிண்ட்ல தான் equilibrium நடக்கும். Then are we good with this? Very similar to what a soap bubble is. Surface tension and inside உள்ள இருக்க air pressure. Yeah, I hope you guys are seeing this.
சாரி, இப்போ வந்து அந்த அமௌண்ட் ஆஃப் ப்ரெஷர் இன்சைட் அண்ட் அவுட் சைட் போறது வந்து ஈக்குவலா இருக்கணும். அதுக்கு ஒரு 0 சென்டர் பாயிண்ட் இருந்து அது ஈக்குவலா இருந்தா தானே அந்த ஒரு மாலிக்யூலோ இல்லை ஐ மீன் ஒரு ஸ்டாரோ அந்த ஸ்பியரோ வந்து இருக்கும்.
அந்த ஷேப்ல இருக்கும். ஆமா,
இல்லைன்னா அது வந்து அந்த ஷேப்ல இருந்து மாறிடும், இல்லை எக்ஸ்ப்ளோட் ஆயிடும்.
that is where we are heading. இல்லைன்னா என்ன நடக்கும் அப்படின்னு.
ஓகே,
ஸோ யா இப்போ நம்ம வந்து ஒரு 100 லிட்டர் பெட்ரோல் போட்டு 1 லிட்டர் பெட்ரோல் பண்ணி, ஏன்னா பெட்ரோல் விலை அதிகமா இருக்கு. ஸோ 1 லிட்டர் பெட்ரோல் போட்டு யார் சம்வேர். ஓகே, அண்ட் அட் சம் பாயிண்ட் இன் டைம் த பெட்ரோல் ஷுட் கெட் ஓவர்ல. கரெக்டா? யூ கேனாட் ஹாவ் பெட்ரோல் எவ்ரி டைம், ரைட்? அட் சம் பாயிண்ட் இன் டைம் த பெட்ரோல் தீர்ந்து போயிடும், ரைட்? ஸோ அப்போ தீர்ந்து போச்சா என்ன நடக்கும்? யூ ஸ்டாப், தட்ஸ் இட். ஸோ இன் த சேம் வே inside a star the fusion happens only till what? Till iron, right? And what happens after that? There's no more fuel, there's no more stuff to fuse together, no more energy. Then what happens is that, but still the fuse on a matter உள்ள இருக்க stuff எல்லாம் அங்கே தான் இருக்கு, right? You get the point? So what happens is that the gravity will take over the entire star. Okay, the gravity will take over the entire star and it will slowly deform the star. Okay, it will slowly deform the star. Fuel koreya, it will go to a point where it is in just that tip. Or tip nadandichna, this entire star would become something else. Okay, of course there's life cycle of star, as he said, white dwarf varum, adu supernova, blah blah blah, all those things varum. But what we are interested in is the black hole. Okay, which star will become a black hole? Which star will become a supernova? That has a limit called Chandrasekhar limit. Okay, it's an Indian name after an Indian. Okay, about 1 something solar mass. Okay, if somebody knows a particular value, please put it in the chat. 1.24.
1.4.
1.4. Oh, 1.4 solar mass. Okay. அந்த லெவலுக்கு மேல இருந்தா இப்படி நடக்கணும். இந்த this is the limit. Now அதெல்லாம் அப்படி தூக்கி வச்சிடலாம். இப்ப நம்ம என்ன பண்றோம் அப்படின்னா, this fuel காலி ஆயிடுச்சு, it is going down and down and down, and at some point the gravity is completely taking over. Okay, the gravity is completely taking over, and that is what we call what?
Black hole.
We call what? Oh, that's it. Yes. That's what a black hole is basically. That so it's like nature trying to prevent to be in one shape, and then that itself becomes a problem at the end. I mean, not a problem, but that itself becomes something tragic at the end, which becomes something called a black hole. Done. And now what happens is that, see, the rest is out of the scope of what today, the things that we are sort of trying to talk today. The whole idea of today's this webinar is to show you that how nature prefers to just follow simple one rule and apply it everywhere, just in a different form. The same concept applied there, but with different force. That's it. You don't find any new different ideas, blah blah stuff and all. So this is how it sort of works. Are we good so far? Is there anything to ask? Anything to any question that sort of pops? Yes, no?
இல்ல bro, அவ்வளவுதான்.
Super. So the kind request for you guys is to start to look for pattern. Okay, that's the easiest way you can learn anything. Then, but எல்லாருமே physics தான். I mean, people who are interested in physics and space and stuff. Yes, I assume that. Hands raise if yes. No one is interested in physics or science. Oh my god, my bad. I just wasted 1.5 hours of the I mean, 1 hour talking to somebody who don't love physics. I mean, who don't love science and stuff of that. Okay, fine, good. So the whole point is, when doing physics, immediately look for something lower. That is how I learned the entire physics thing. Okay, every single thing here is interconnected. Okay, if I can connect you with the least action principle and other stuffs. Okay, everything follows very similar pattern. Okay, அதனாலதான் நமக்கு சொல்லுவாங்க பேசிக்ஸ் ரொம்ப முக்கியம், பேசிக்ஸ் நல்லா கத்துக்கோங்க அப்படி சொல்லுவாங்க. தட் த ரீசன் இஸ் பேசிக்ஸ் கத்துக்கிட்டா இதோட அப்ளிகேஷன் தான் would just be there, slightly different from that's it. Okay, so always look for these basic stuff and then try to connect with what you have learned. Okay, got it? Are we good with this? Thankfully I've completed in just an hour. 59 minutes complete பண்ணிட்டேன். So if you have anything to ask, if you have anything to share, you can share. நான் இப்போ வந்து ஒரு கிளாஸ் முடிச்சு வந்தனால எனக்கு கிளாஸ் வருது. Don't mind it. It is on class கிடையாது. I'm just sharing what I know and you guys sharing what you know. I am going to give you an offer and I'm also going to ask you a suggestion. First I'll ask a suggestion. Okay, அடுத்த week we'll have an open talk. Meaning இந்த மாதிரி இருக்காது. நான் வந்து ஒரு கான்செப்ட் உங்களுக்கு ப்ரெசென்ட் பண்றேன் அப்படி இருக்காது. Anybody can take given we'll share the topic. Okay, on the topic anybody can talk for like a few minutes. Okay, so the request is, what topic should we have? எந்த டாபிக் வச்சா நீங்க வருவீங்க? Okay, just put that topic down. It's very hard to find topic that matches your interest. Okay, because if I were to think, I'm like thinking either little too much or little less for you guys. So நீங்களே கொஞ்சம் சொல்லிட்டீங்கன்னா I can think through that. So that's the request that I have. The offer that I have is that we have done this before, like ஒரு 500 people முன்னால இருக்கும்போது, single Promethions group இருக்கும்போது we have done this. I want to try doing that same thing again. என்னன்னா we invite people to talk. Okay, I am ready to invite other people to talk, but I want someone from here to come and talk. Okay, if somebody is interested to come and present some idea of which you have, you are welcome to talk. That's the offer that I'm sort of giving you. Don't think it's like சும்மா அது சொல்றேன் ஒரு 20 பேர் இருக்காங்க அப்படின்னு சொல்லிட்டு. The whole point of why I started Promethions is that எனக்கு ஒருத்தர் ஆப்பர்ச்சுனிட்டி தரல. ஓகே, நான் கேட்டு எனக்கு ஒருத்தர் தரல. So I don't want to feel the same. I don't want to make you feel the same. Okay, I want you to. There's no right wrong. Nobody is going to judge you. Okay, as long as you come and present what you know. Okay, this will sort of help you to become someone who is better. That is how I grew. So I'm just giving the same thing. If you're interested, you can just DM me, or you can just put it here also if you feel a little off about DMing. So yeah, different ideas about physics with different examples that connects the same. Oh my god, எனக்கு புரியல அச்சு விஜய். Different ideas about
quantum
physics.
physics. About quantum
About
physics.
quantum.
இல்ல ப்ரோ,
About
இப்போ
quantum.
ஒரு எக்ஸாம்பிள் வந்து சோப் ஆப்பிள் வச்சு இப்போ ஒரு பேர் பத்தி பேசணும்ல. ஸோ அந்த
Okay,
மாதிரி
okay.
ஒரு
இந்த மாதிரி சொல்றீங்க. Okay, okay, okay.
Then magnetic
Thermodynamics.
force. About
Sorry?
about magnets and electricity.
Magnets and
Then
electricity.
then solar system and the Milky Way galaxy.
Milky Way galaxy.
Universe. Yeah. Then uh,
Okay. Human
Anna,
brain.
about the
Science
science
behind
behind volcanoes.
volcanoes. Okay, okay.
I got a doubt.
Yeah. Something about
thermodynamics related?
biology. Thermodynamics?
Is related to classical or quantum? Or both?
It belongs to statistical mechanics. Hey, statistics follows both classical and quantum. So I'm on the safer side saying it follows this thing. At temperatures, you learn about 3 different types of statistics. Boltzmann, Maxwell-Boltzmann, Bose-Einstein, and Fermi-Dirac. At lower scale, everything behaves like Maxwell-Boltzmann. I mean, sorry, at a higher temperature, everything behaves like Maxwell-Boltzmann, which is classical. But at certain temperatures, everything becomes uniquely separated. Bose-Einstein or Fermi-Dirac or different. So safe to say both.
Because I got a war with the Instagram guy about this thing.
Oh,
Classical
war.
quantum one.
Okay, okay.
Night ஒரு மணி வரைக்கும்.
Please.